Huh?
Standing on an edge.
Let's not breathe then. Okay, so today is going to be quite. It's moving. Yeah, today is going to be quite short one. Basically, it's all about triggers. And I've just realized that we haven't done any indexation as well. So the next one is going to be on indexes. Just basically very briefly what indexes are, how to index your database correctly. What's a clustered index and what's not clustered index, all that kind of stuff. But today we're covering triggers primarily. Does anybody know what trigger is and what it's used for primarily?
Kick off another process. Essentially, when something happens.
No, it's a little bit on a gun to shoot. That's the trigger. That's the one we're talking about today. No, it's, well, yeah, basically it's on a table. When you insert, update, or delete any data, you can trigger another event to happen in a database automatically. So what that does is, let's open SQL Server Management Studio, and I'm actually connecting to my computer that is behind that wall today. So I've got the Adventure Work database here as well. So imagine basically we've got a table here, product inventory. What I want to do is I want to implement a functionality. Whenever I change any values in that table, I want to record its audit trail. So every time I insert a new data into this table, I want to record the fact that I've inserted new data, update, basically record that update in that in the audit table. And also when I delete data, I also want to record the fact that I've deleted some data, delete some quantities. Basically to keep the full audit trail. Also, what we're going to look at is implementing the trigger in a way that it acts instead of some operation. So this is where we're trying to delete some data, and instead of actually deleting a row, we're going to mark it as logically deleted. Right? So all very cool, and it's very kind of standard functionality within SQL Server. Not used very, very often. It's a very good piece of functionality, but it needs to be used quite carefully because triggers, as any other process, would actually trigger, a lot of work for the SQL Server to do. So mainly they're used for validating data. If you're trying to insert something into a table that needs extensive validation, it's used for basically inserting maybe some primary keys if they don't exist in the other table. For example, if we're trying to insert some data into product inventory and the location ID doesn't exist, what we can do, we can create a trigger instead of insert that will check whether location ID exists before we actually insert the data. And then we insert the location ID into that table first, get its new primary key, and then we insert the row into product inventory data. So that will enables us to to make sure that we can populate the database with default values for primary keys, for some reference in tables. Okay, let's get going. And what we're going to do is pretty much we're going to implement a table called product inventory, and that table is going to be pretty simple. What it's going to contain is basically row ID of the row that we're inserting when we've done a change. So this is audit date. Product ID, product location ID, so that basically our relation to product inventory. Location ID that we've inserted, shelf ID that we've inserted, bin, and new quantity that we've inserted as well into that table. Okay, so let's create this table. And now that we've covered kind of the schema, do you remember the last session we covered schemas of the database, and it's very apparent what it's used for in AdventureWorks database. As you can see, pretty much the tables that are allocated to different departments allocated different schemas. So effectively we can create a user that is allocated to that schema that can only access those tables. So for example, we can create a new user that is allocated to a schema called human resources, and we allow that user to only select data from human resources. So they won't be able to even see any other tables in this database. So that's how we can segment database across different departments, across different things that database does. So all the data is contained within the same database, and we can have a overall covering schemas that then can access multiple schemas effectively based on that schema ownership. But primarily, basically, this is very apparent in AdventureWorks, where the database is segmented by schemas. Okay, so Now, that's pretty much what I put the production schema in front of our product inventory audit table, so that we can also allocate that table, product inventory audit, to that production schema. Okay, so we now have this new table. If I click refresh, we will have it. It's there. Okay. So what I want to do is, first of all, when I insert new data into this product inventory table, I want to record the fact that the new record appeared, and I want to record its values. So what we need to do is to create a trigger in this manner. Okay, create trigger, then give the trigger a schema as well, because that's part of the user permission, overall user permission as well. So we need to allocate the schema to a specific schema. So for example, if I gave this trigger a different schema, like for example DBO, and then a user with permission to only insert data into the production schema, it's trying to execute this, it's trying to insert some data, he'll get a failure because there's a trigger that allocated to product inventory that is under different security context. Okay, so that's actually another way of ensuring that we can secure the insertion of the data. So for example, we can, it's a very daft way of doing things, but this is sometimes quite a valid point. So we can create an insert trigger with a different schema to the one that is actually the primary schema of the actual table, and then only the users under the ownership schema can actually insert the data. But in our case, we're going to keep it simple and just allocate to the same schema, give it, so that's the name of our trigger, then on which table we want to implement that trigger, and then the statement that basically states that after the data has been inserted, so there's a called after the insert, we're going to execute this bit. So within the trigger itself, we've got two temp tables. They're called inserted and deleted. So inserted, as the name suggests, is all the data that we have just inserted into the table. So and deleted is the one that we've deleted. In the update case, what happens is where all the rows that have been updated, all the values are going to get put in deleted table, and all the updated values, the new values, are going to be inserted into deleted or into inserted table. Okay, but in our case, because we're doing it for insert operation, all the data is going to be contained within inserted, and it's going to contain all the columns that product inventory has. So all of those columns. And we can just basically select from it. So in our case, what we're going to do is we're going to insert data into product inventory audit, all those columns effectively, and then get the current date, then newly inserted product ID, newly inserted location ID, newly inserted shelf, bin, and quantity from inserted table. Okay, so let's execute that, and now on the triggers, we're going to see that there's a new trigger. We can disable it. How can we disable it? There's a way to disable the trigger as well. I'm not entirely sure where it's, there's a basic SQL DDL command that can alter a trigger and disable it. It should usually be on the SQL Server Management Studio interface. But anyway, so if we disable a trigger, it just basically means that it's not active. And so we can create them, basically disable them and enable them whenever we need to. All right, so now what I'm going to do is I'm going to go and insert some data into product inventory for all those columns, and then values. Just a little hint, when you write in a query, you don't mess up the number of columns and you know where they are, just basically paste the columns that you insert in right in here, and then just replace them with the values you want to insert. Like in our case, what I want to do is to do something like this. S1, then bin will be B1. New quantity is going to be 100. Row good is going to be new ID. Sorry? Bin is integer indeed. that already exists, that already exists, that already exists. Okay. Sorry? Product shelf doesn't exist. Yes. So we inserted some data for product 388 in location 2, blah, 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 this kind of stuff. So, and now let's have a look at what's actually got inserted into our product audit trail. So select from audit trail, and then we can see that we've got new record in there. So if I try to insert something new, okay, let's guess the one that doesn't exist. 3, maybe? Yes. So we've got new records there. Okay, so that's trigger for insert. Okay, we can do exactly the same thing for deletion. Like, for example, in our case, what I'm going to do is I'm going to create a very similar trigger to the insert one. Again, create trigger, which give the trigger a name. So in my case, I'm going to just prefix it with D for deleted. And then on this table, and then after deletion, we're going to do this operation. As you can see now, instead of selecting from inserted table, we're selecting from deleted table. And again, that deleted table will contain all the columns that are referenced in that table. And then instead of a quantity, I'm going to put quantity multiplied by -1. So I'm just going to put a negative of the quantity we actually had in that row to begin with. Okay. So there you go, and what we're going to do is I'm actually going to delete from product inventory where product ID location ID is 2. Okay. So one record has been affected, so we have deleted some records. Now I needed audit. Okay, now we can see there's a new record there, row ID 3, so that's the latest one we've inserted. We've deleted this product, and it recorded which shelf and what bin it was in, and put the quantity as negative. Okay, similar story with the update trigger. Okay, but in this case, what I want to do is I want to insert the data in the product inventory audit table whenever we update any data, but only if the quantity has changed. So I don't care about if we change the shelf or a bin of that inventory. All I care about is if the quantity has changed, I want to keep a record of it. And the way I would do this is I'm selecting all the table, all the data that we've just updated, so the new values from inserted, that's where they're going to be. Then join to deleted table by product ID, well, by its basically key. So, and because that's our key, product ID and location ID, that's how we can uniquely identify the row, and then checking that the quantity is different. Okay, so let's create that table, and what I'm going to do now is update product inventory, set quantity to quantity +1, product ID 388, and location ID is 2 or 3, yeah, 3, basically, because we've deleted number 2. Okay, there you go. And now if we look at our product inventory audit table, we can see that there is a change there occurred. So the new value is 101. So if I execute this again, we're going to have a new value. And then if I, let's say I want to change the bin to 2, we're not going to see a new record in the audit trail because the quantity hasn't changed. Okay, so that's the basics of a trigger. What I want to also demonstrate is how to do I mean, in this case, what we're doing, we executing some operation after the event, after we've actually inserted some data. The data hasn't actually yet been applied at this point to the table itself. What's happening in the SQL Server engine side of things, it's doing all the transactions, all the updates and everything is basically in transaction logs. Basically, those transactions happen, but they don't actually get written into the database itself. So at this point, we can actually roll back all those transactions. For example, if there's an error in the trigger itself, we can roll back all the transactions that happened, in the parent table, and they're not going to get actually physically applied to the table. But what we can also do is we can do so-called a trigger that is typed as instead of this operation. So instead of deleting data, we're going to execute this script. Okay, so the actual deletion of the data is not going to happen physically on the table. It's going to happen in a transaction log, and then from the transaction log, from the transactions itself, the data will be put in a deleted temp table, and from there we can do some other things. We can actually physically apply some different operation to the product inventory table. So in this case, what I want to do is when we're trying to delete an inventory record, instead of physically deleting that row out of the table, I want to mark it as biologically delete. All right. So in case of normal SQL statements to the developer, for example, nothing will actually change. They will still be able to literally go and try to delete rows out of the table. But on the database level, on the database architecture, we're not physically going to delete those records. We're going to mark them as biologically delete. So for that, I need a new column in the my product inventory table. Alter table, then add biologically is logically with 2L.
Looks wrong.
Maybe 3L, 4. What if I do this? Does it work? If I wanted to name like this, what would I do? Yeah, like that. Then I can do anything I want there. I can have this, I can have this, I can have all that kind of stuff. In fact, I can even probably have Russian characters in there. Okay. Logical. Oh, there you go. This is, if you don't know how to spell something, find another word. Okay, so I'm going to implement a new column called biological delete. And it's by default, it's null. I can basically I can define it as being a as default column. For example, what I want to do is, let's rewind back because I've just skipped that bit very quickly. So at the moment, all the columns are null. So if, for example, by default, we are kind of assuming that biological delete can't be null. It can be only true or false. It can be something in between. We're not dealing with quantum physics. It has to be 0 or 1. So when we're trying to do something like this, where biological delete equals 0, this is the normal statement that anybody would write, we're going to get no rows because all of them are actually null. So when we kind of add a new column to the table, we want to make sure that all the values there have got some default value. Now, default value would be 0, biological delete, not true, so the row is active. So what I can do is when I create a column, I can give it a default value. And I also need to specify that it cannot be null. So add biological delete, this is its type, bit. It can't be null, and it will have a default value of 0. Yes. Okay. Now, if we have a look at the values of those columns, they're all null. And of course, basically, that will be an applicable SQL statement. Okay, so we now got a biological delete column. And now if we go into this, where is our table? There you go, this trigger, pretty much exactly the same. There's a create trigger as the product inventory. And then on which table, instead of then the operation, instead of deletion, we're going to do this. So in this case, what we're going to do is select all the rows from deleted, then match them up to product inventory by its key, and then we're going to mark them as biologically deleted instead of actually deleting that row itself. Okay, is it going to run? Why? Correct. So what do I need to do? Sorry? I can drop that trigger. Because if the thing is, for example, in this case, if I go and create a new trigger with a different name, what's going to happen is we're going to run two triggers. One of them is going to run instead of deletion, the other one is going to run after deletion. Well, because by the logics of it, instead of deletion will run first, which will never trigger the actual deletion trigger. I think. I don't know, let's give it a go. To be honest. So now we have two triggers there. In fact, let's not mess around with this, and let's actually do this properly first, and then we'll give that, we'll run that experiment, what's actually going to happen. So I'm going to delete this delete trigger and create new trigger as a normal one, just one trigger that does the instead operation. Okay. So now what do we have in here? We've got update statement, and now let's try to delete from production, product inventory, where product ID is 388 and location ID is 3. I think that's right. Okay, so let's run that, and it's telling me that one row has been affected. Basically, that's actually grabbing it from the transaction log. So all of the rows affected within the trigger is not going to get reported as modified rows. Okay, and if we look at the audit trail, we're going to see now we're not going to see anything. Well, yes, okay, we're not going to see anything because there wasn't any quantity change. We just deleted a row. Okay, but if we select this row from. Now you can see the row is still there. It's just we changed this value to biological delete. Okay, so triggers actually can be nested, and they also all of them will fire at some point. So for example, if we implemented multiple triggers that do after update, all of them will get fired. You know, one after another, or yeah, I think it's one after another. I don't know whether there's any way of actually determining which priority they will have, actually, but it's something to research for yourself. Or maybe they will even get fired all at the same time. I'm not entirely sure how the multiple triggers actually do work in this case. But, so we have this, since in this trigger, we're actually doing an update on the product inventory table. So when we're doing this bit, obviously this trigger will get fired as well. So in this case, what we can do is we can implement or newly inserted data b logical delete not equals deleted b. Okay, and we're going to alter this as well. So now, whenever our quantity changed or we changed the status of biological delete, we're going to insert the record. But also here, I want to insert whether there's been a deletion, so negative stock, or if it's normal update, then we just put a no value in there. So here I can do actually check for whether it's a deleted row. And in this case, I'm going to put case newly inserted data b biological delete equals 1. Then I'm going to multiply it by -1. And in any other case, it's going to be multiplied not by 0, by 1. case when. Okay, so when the logical delete of this record that we're actually updating is equals 1, which means we deleted the record, which means we have to put in the audit trail a record with a negative value, or we just basically multiply it by 1. Okay, so did I just misspell logical delete? If you can't spell, copy and paste. Okay. Right. Let's find another row that we can delete. Okay. There's product 1 and location 1, and we're going to do exactly this. Product 1, location 1. Now delete from it. Let's see that it actually deleted it. Yeah, we've got logical delete as 1, and also in the audit trail we now have a record saying that we've deleted a table or deleted a row. Product 1, location 1, and this is a negative value telling us that we have deleted that information from it. Okay. What time is it? Anybody knows what time is it? Time. Doesn't matter. Okay. So let's give it a go and actually implement 2 triggers. So what's going to happen if we have 2 triggers? There you go. This is another. No, this is the update trigger. This is our normal after deletion trigger, and what we're going to do is going to go and insert it and give it a new name. Okay, so this is a bit of a kind of a confusing case because we now have a trigger that does something instead of deletion, and we've got one that is actually doing the bit that does the actual deletion. And here I'm going to go and comment this thing out, where we have the check-in for the logical delete stuff. So we can kind of revert back to the situation we had before. What is our statements? Okay, let's run some examples to see what's actually going to be happening. I'm just going to close all those windows because it's very confusing. Okay, there you go. Let's find in the row to try to delete 1 and location 6. So 1, location 6. Okay, something did happen. Okay, so evidently the second trigger doesn't even get fired because there is no operation as delete. The first one takes precedence and basically overrides the second one because the second one is after deletion, and that after deletion itself, the transaction never actually happens. Okay, that's about it on triggers. Any questions? Any at all? Anybody? Please.
I suppose the biggest thing though is you can end up with a massive audit. If you put too many of those in and you're doing a lot of data, so you can end up clogging your database.
Yes, that's exactly what we're doing in our system, to be honest. Well, the way around it is to delete some old audit trail records. Or what we're doing with stock levels, I mean, you've heard this, is we were actually combining them. So because there's a lot of stock changes happening during the day, and we don't need them, all of those changes throughout the day. We don't need the exact trail that this stock item went out with this order, etc. After about 3 months, what we're doing is we combining them into one record. So there's only one record per day. That's one way of doing things if we don't need that amount of data. The other way of doing things is to put the audit information into another database as well. So we're effectively just not clogging that up. If there's tons and tons, absolutely millions and billions of transactions that we need to actually keep track of, one of the ways of doing things is to keep them in a local table, in a local tables, and basically then every day move them across to like a caching server or something like this. So there are ways of doing things, but triggers are used not only for audit trails, don't get me wrong, they're used for all sorts of things. You can put things in there that, for example, in our case, when we change the stock, we know we've changed let me just put it this.